Here is the problem set related to amides, amide synthesis, names, and hydrolysis. The first question is to draw these structural formulas for the amide synthesis. Now, in my lecture video, I explained the amidation reactions. So, we know that amidation reactions or amides are synthesized by reacting a carboxylic acid and ammonia or a primary or secondary amine. Now we have the carboxylic acid here and ammonia. Now to determine the structure of the amide, I'm going to take the carboxylic acid first. So you can just um, take the fragment from the carboxylic acid which makes the amide. Now ammonia is given as NH3, so I will just draw it like this. So I can easily figure out which fragment goes with the carboxylic acid to form the amide. Now these the fragments that are in these red color boxes will combine to form the amide. Now what happened to the other fragments? So OH and hydrogen will just combine to form the water. Now the question is asking on the structure for the amide. So we will take the structure. We will combine the two fragments, carboxylic acid fragment and the fragment from ammonia to combine. And we need to form the amide bond, right? The amide bond is the bond between this carbon, carbonyl carbon and nitrogen. Remember that. So this is the new bond forms, okay? So this nitrogen will attach to the carbon and there are two hydrogens attached to nitrogen. We need to draw that as well. So this is the amide forms. Now the question is asking for the condensed structural formula. So the correct answer would be CH3CONH2. I just condensed the NH2 into as an the nitrogen and two hydrogen atoms into NH2. So this is the correct answer for this question. Okay, so that's the same way you have to follow in all the other reactions as well. I will just quickly go through part B, question B. Now to determine the carboxylic acid fragment. So you just need to eliminate the hydroxyl group of the carboxylic acid and all other atoms in the carboxylic acid will remain to form the amide. And we have here NH2. Now this is a primary amine. So one of these hydrogen atom from nitrogen will just combine with OH. Okay, so we can just figure it out like I'm gonna show it like this without showing H2. I just draw the two hydrogen atoms attached to the nitrogen. So just to simplify it for you. Now this will go as a water molecule and amines fragment that makes the amide would be this one, this part. So we just have to combine this carboxylic acid fragment and amine fragment to make the amide bond. So just draw the carboxylic acid fragment as it is without changing anything. Whatever the alkyl groups present will come with the with this carboxylic fragment. That's it. And then we need to make the amide bond. This bond is with this nitrogen atom. Okay. And all other atoms present with this amine will remain as it is, CH2, CH3. So that's the amide that makes the amide that forms by reacting these two compounds. Okay, and we have question C here. So always you just have to eliminate the hydroxyl with one of the hydrogen atom from the amine, right? So I'm gonna draw it like this. So these two will combine to form the water molecule. Now the carboxylic acid fragment would be this part, and the amine fragment would be this part, right? NH. Um, and then those two will combine to make the amide. So I'm going to draw the carboxylic acid fragment, the same atoms as I see here um, in, in the amide. Okay, this is the carbon, right? Now, this is the amide bond, carbon and nitrogen. Okay, this is the nitrogen atom that I just copied this nitrogen here because this carbon will bind to the nitrogen atom to make the amide bond. Nitrogen and this one hydrogen atom and then the benzene ring. So that's the amide forms by reacting the carboxylic, given carboxylic, and this compound is aniline. So that is, so we have this new amide formed here. So those are the structures of amides. The answer is this one, and this is the answer for question B. Okay. The next one, write the IUPAC names of the following amides. Now, in order to determine the IUPAC name, so as I explained in my lecture, first you need to start with the carboxylic acid fragment. Okay. Now, since this is an amide, now we are going to change this name again into an amide. The rule is, the IUPAC rule is to replace the oic acid with amide. So that would be propanamide. Okay, that's how we come starting from the number of carbon atoms to give the oxalic acid name and then the amide. Okay, now this is a propanamide. Now in the amine group, there is an alkyl group connected to the nitrogen atom, right? So we have to give that name as well. So this is the alkyl group, which is ethyl. It's an ethyl group, and it is connected to the nitrogen atom. So we have to specify that in the name, in front of the name. So the name would be N dash. The alkyl group is ethyl, N-ethyl propanamide. Okay, so that's the correct answer. N-ethyl propanamide. Okay, now question B. Question B is an aromatic amide. As always, we need to start with the carboxylic acid group. So I'm going to separate the carboxylic acid group. So this is the carboxylic acid group. So how do you know which one is carboxylic acid and which one is amine? So always look at this bond, okay, where this carbonyl group and the nitrogen atom. So this is the amide functional group. So the fragment that comes from the so you just have to split the bond from here. This is the amide bond. You have to split carbon nitrogen bond, and the fragment that present with this carbonyl group is the carboxylic acid fragment, and the fragment that present with this nitrogen atom is the amine group. Okay, so that's why I'm breaking this bond or splitting this bond from here. So this is the carboxylic acid, and the this part is the amine group. We'll start with the carboxylic acid name or benzene ring connected to the carbonyl group. Corresponding carboxylic acid is benzoic acid. benzoic acid is the carboxylic acid that formed this amide. So in order to convert this into an amide name, we will just replace ic acid with amide, benzamide. Okay, so this is the carboxylic acid fragment name for this amide. Now we will go to the amine part. In the amine part, we see there is a methyl group attached to the nitrogen atom, right? So this is a methyl group. Um, so that means, so this is a methyl group connected to the nitrogen. So we have to specify that name as well. In front of the name, you will give N-methyl benzamide. There is no space in between methyl and benzamide. Okay. So that's the name of the question B. Question C. So in question C, what is the carboxylic acid? So the carboxylic acid has 1, 2, 3, 4, 5, 6. 6 carbon atoms. So that is hexanoic acid, right? So when hexanoic acid converted to the amide, it will be hexanamide. And we don't need to worry about the amine here because there are no any alkyl groups connected to the nitrogen. That's only 2 hydrogen atoms. So the name would be just hexanamide. So that's the correct answer. Okay. Now, question 3. Draw the structural formula for the products obtained from the hydrolysis of the following compounds with hydrochloric acid. Now, I have given a detailed explanation of acid hydrolysis and base hydrolysis in my lecture video. If you didn't watch that, please watch that before you come to these questions. Now, we will see what are the products that comes from the acid hydrolysis of this particular amide. Okay. Now, what happens here? You will just have to split the amide bond. The amide bond is here, the carbon-nitrogen bond, right? You will split the amide bond, and then since this is an acid-mediated hydrolysis with hydrochloric acid, the products would be carboxylic acid plus ammonium salt would be the products. So now it's very easy for us to figure out what is the carboxylic acid that comes from this amide. The structure would be just, you just have to add a hydroxyl group to this side. Okay, so I'm gonna draw that particular carboxylic acid. So what is this carboxylic acid? It's ethanoic acid, right? It doesn't ask for the names, just the structure. So this will be one product. And what is the ammonium salt, which forms by this one? To make the ammonium salt, I will just add a hydrogen atom and HCl. Okay, hydrogen atom to here, and then HCl. So this will make an ammonium chloride salt. So the product would be ammonium ion and chloride ion. So when it asks for the products, don't put any plus sign here, okay? Because this is one compound, and we don't want to put a bond here either, because these are ions, and we show that as separate ions, a positive ion and a negative ion, just like this. Okay. In question B, so we have here an amide. So first I will just split the amide bond, and then to determine what is the carboxylic acid, you have to add a hydroxyl group to this side, and then the ammonium salt would be here. You just have to add two hydrogen atoms and a positive ion. This is a positive ion, and then chloride, right? So this is just the one step process, but I have explained what exactly happens in acid hydrolysis and base hydrolysis in my lecture video. If you so you have to watch that if you haven't done. That will give you a better understanding what exactly going on in hydrolysis. So the carboxylic acid product would be propanoic acid like this, plus again it's the same ammonium salt as in the previous question, ammonium ion and chloride negative ion. Okay, so those are the two products. And question C, a little bit different. So it's not ammonia this time, it's a different amine that forms from the acid hydrolysis. So I will just add a hydroxyl to make the carboxylic acid. So the carboxylic acid would be CH3, CH2, CH2, and COOH. And what happens to the amine side? Now we have to add, let me show it here. So you will add a hydroxyl to this side and a hydrogen atom to this side, and HCl will combine. So another hydrogen atom to this one to make it positive ion, and there will be a chloride negative ion, right? So this will be the ammonium, the methyl ammonium chloride. So the structure will look like this. CH3, then N. How many hydrogens are there? 3 hydrogen atoms, right? CH3, NH3 plus chloride ion. Okay, so those are the two products. So to determine the products, again, split it from here and add a hydroxyl group to this side. So why we are adding this hydroxyl group and hydrogen? Because it's hydrolysis, means it breaks up this bond in the presence of a water molecule. So that's why we need to add OH to this side and a hydrogen to this side. And since this happens in the presence of HCl, HCl will make this ammonia the ammonium chloride. So that's why. So there will be two hydrogen atoms. One comes from the water molecule and the other hydrogen comes from the HCl. And as the nitrogen gets 4 bond, it becomes positively charged. Okay, that's what happens in the reaction mechanism. Now we will see what are the products. One product would be benzoic acid. And the other product would be ammonium ion and chloride ion. Okay, so these are the two products that comes from this benzamide. This is benzamide acid hydrolysis. Okay, I'm going to show you an example question on acid hydrolysis products of the amides. So this is the question 14 in your homework. And this has 4 questions, and I'm gonna choose this particular question because this is the most complex structure in this hydrolysis question set. Let me show you how to use the drawing tool to enter your answers as carboxylic acids, ammonium ions, and chloride ions. Okay, so now I already discussed the answer in the problem set. So I will just draw the products here. Now, the carboxylic acid product would be the butanoic acid. So just use this zigzag line here and draw the carbon atoms. So this has 4 carbon atoms and the last one has to be the carbonyl carbon. And click on this bond tool here to get the double bond. Now we got a double bond. So click on the oxygen atom to make this CH2 an oxygen atom. Okay, so this is the aldehyde, right? So we need to make it the carboxylic acid. So click on a bond here and we will make this methyl group and a hydroxyl group. Okay, so that's the carboxylic acid, the butanoic acid. Now the amine would be, will change to methyl ammonium chloride. That's what we got in the problems. Just click on this zigzag bond tool and so I got 2 methyl groups. That's not what I need. I need methyl ammonium. So I will make this one an NH3 plus. So to change it, click on the nitrogen atom and bring it here and click there. So this is methyl amine, not methyl ammonium. To make it ammonium, you can just go and click on the positive charge here to increase charge. Okay, and bring it here on the nitrogen atom and click there. So it made NH3 plus. So this is methyl ammonium and the other product, so this is methyl ammonium chloride is the second product. We still need to show the chloride ion. Click on the chlorine atom and click there. And now it shows as HCl. To make a chloride ion, Cl negative ion, click on this negative ion tool to decrease the charge and bring it back and click on the chlorine atom. So that made HCl a chloride ion. So it's relatively simply a simple way to make the ions of the ammonium ion, ammonium positive ion and chloride negative ion. So those are the products and you don't need to add the plus charge or you don't need to add a plus sign to show there are 2 products. No plus signs or no bonds in between ammonium and chloride. So that will accept your answer. Just follow the same way for the other structures as well. So I have already discussed this in my problem discussion. Now the fourth question is draw the structural formulas for the products obtained from the hydrolysis of the following compounds with sodium hydroxide. Now this is a base hydrolysis. In the base hydrolysis, the products would be, I'm going to write that here. The products would be carboxylate salt, right? Carboxylate salt, the sodium salt of the carboxylic acid plus ammonia or amine. Okay, amine or ammonia would be the products, the 2 products. So in the first one, we have this structure. So first, as always, you need to break up the carbon-nitrogen bond. Okay, carbon-nitrogen bond. And in my lecture video, I showed you a shortcut to make to predict the products faster, right? So you will basically suppose that we have this NaOH. So this is what you will do. I'm going to extend this splitting here. So you will add ONA to this carbonyl carbon and a hydrogen to the amine side. Okay, that's the shortest way to predict the products, but I have given the whole mechanism, what happens exactly in 2 steps during base hydrolysis. Okay, if you didn't watch, please go back and watch that because that's very important to understand logically how these products are formed. So I'm gonna use this here. So as a shortcut, you just draw the carboxylic acid fragment just like you see here, and then carbonyl carbon is there, and then add this ONA. So this O negative and Na positive. So this is the sodium salt of the carboxylic acid, or we call this as carboxylate salt. Okay. So this is one of the product because it first forms the carboxylic acid, but in the presence of sodium hydroxide, which is a strong base, that carboxylic acid will form this sodium salt. Okay. But ammonia will just remain as it is, no change for that one. So the second product would be NH3. How do you know? You are just adding this hydrogen to this NH2. Okay, it becomes ammonia. Just like that, you can try what is the product here. So just split the carbon nitrogen bond and then do the same thing, NaO here and H here. Okay, so add the ONA to the carbonyl carbon and then add this hydrogen to the nitrogen. Okay, so it's very easy, right? So the products would be CH3. So all the acid fragment that you see here has to be copied down just as it is. CO, O negative, and sodium plus. One important thing, okay, no bond in between oxygen and sodium. You just keep it as a space. And this negative charge must be there on oxygen atom, and the positive charge must be there on the sodium atom. Okay, that's how you show the sodium salt. And the other fragment would be just copy down the same thing from the amine, and the hydrogen atom comes, and that will be the that's diethyl amine. That will be the second product. Okay, and in C, now again do the same. Break up the amide bond, and NaO will be in the acid side and hydrogen will be in the base side or the amine side. Now the products would be sodium salt of the benzoic acid, sodium benzoate, and the amine and one hydrogen, right? So that's the amine, corresponding amine that resulted from this hydrolysis. So these are the base hydrolysis products. Always you get the carboxylate salt and the amino ammonia. If it has NH2, it becomes ammonia. If it is a primary or secondary amine, then it becomes the corresponding amine. So this is how you predict what are the products. Okay, let me show you how to use the drawing tool to answer this question. So this is the last question in your homework problem. So I will do the last one since this structure is looks a little bit complicated. So to determine the product, so it's asking to draw the structures of the products from the hydrolysis of each of the following with sodium hydroxide. Now, number one, split this bond, carbon-nitrogen bond, and then what you get is the carboxylic acid, right? And the carboxylic acid need to be given as the sodium salt. So just copy down the carboxylic fragment as it is So to do that, I'm going to take this. So I have CH3CH and take a bond and chlorine atom here. And carbonyl group. Okay, so that gives where I actually drew the carboxylic acid fragment. Now I have the carbonyl carbon. I need to make this the sodium salt, right? Carboxylate salt. To do that, I will first add the oxygen atom here, and I'll give a negative charge on the oxygen atom. Okay, so this is the carboxylate ion. And to add the sodium, we need to put the sodium positive ion, right? And there are no sodium ions here in this side. So click this periodic table and get the sodium atom. It's here, click on that, and then place the sodium atom with a positive ion. Okay, that will be the sodium salt of the carboxylic acid. The other product would be the amine, the given amine. So I'll start from this end, CH3, CH2, and then attach a nitrogen atom to this carbon. It made NH2, and I'm going to attach a methyl group to this nitrogen. Okay, so that made a methyl group. So we have, I think, yeah, that's it. So we have ethyl group attached to nitrogen and a methyl group attached to nitrogen, and then hydrogen should be there because remember, ONA comes to this side and hydrogen goes and bind to this nitrogen atom. So these are the two products of the base hydrolysis. Okay. Again, if you didn't watch the base hydrolysis video, the lecture video, please go and watch. It explains how these products are formed. The logical explanation is given there in 2 steps. Okay, so you can click submit, and then that will take the answer. Just like that, follow the same way to answer these questions as well. Don't worry about the structures. You do the same thing. Break up the amide bond and then add ONA to the carboxylic acid fragment and a hydrogen atom to the amine fragment. Okay, so this is the end of the problem discussion. I hope this will help to answer your questions in homework. But if you have any other questions, please don't hesitate to send me an email or attend my office hours. Thank you.